For these notes, we will be focusing on proving special quadrilaterals, or proving the properties that make them what they are. So for number 1, we're asked if the polygon A, B, C, and D is a parallelogram. We need to prove or disprove this assumption. Well, what we know about parallelograms is that all opposite sides are parallel. If you can prove that every opposite side is parallel, you've proven a parallelogram. So with that known, we have to find the slope for AB, DC, BC, and AD and see if they match up. Now remember, the slope formula is y2 minus y1 divided by x2 minus x1. So for this, let's find the slope for AB. When you have a coordinate listed as the second one in the segment, we're going to consider this your second point. So we need to start with the y value for B over the x value for B as well. So currently you should have 3 over 0. Now we need to find the difference between B and A, which means we have to subtract on the top the y value for A, which is 2, and the y value, or the x value for A, which is 3. If we solve algebraically, your fraction, or your slope, should come out to be 1 over 3, which means that your slope for AB is 1/3. So we need to see if DC is also 1/3 for its slope. MDC will be written as 0 over 4, and then minus -1, and minus 1. You should have 0 minus -1 up top, 4 minus 1 on the bottom. And when you solve, you'll have a slope of 1/3. Using the slope formula, we just proved that AB is parallel to DC because they both have the same slopes. Next, we need to prove that slopes AD and BC are also parallel. So again, we'll have the slope of AD be -1 minus 2 all over 1 minus -3. If I were to solve this algebraically, I would have -3 over 4. Repeat the same process for slope BC. You should have 0 minus 3 all over 4 minus 0. Again, taking the difference of our y values and dividing it by the difference of our x values. Your slope will end up being the same as AD with a value of -3 over 4. Using the slope formula, we just proved that side AB is parallel to side DC, and that side AD is parallel to side BC. Now that we've done that, let's take this information and plug it in to our proof. Create a statements and reasons chart below, and start with what we know, it being our slopes. So your first statement should be MAB is equal to MDC, which is equal to 1/3, as well as MAD is equal to MBC, which is equal to -3 over 4. And the reason is due to our slope formula. As stated before, when your slopes for two different sides are the same, we can claim that they're parallel. So since the slope for AB is equal to the slope for DC, we can say segment AB is parallel to segment DC. We can also state that segment AD is parallel to segment BC. And since the slopes were the same, we made this statement true. Your reason for this should be the definition of parallel lines. And finally, since we proved that we had two sets of parallel sides, you're going to end your proof by saying A, B, C, D is a parallelogram by the definition of a parallelogram. Once more, we're applying the definition of what we know about parallelograms to the shape itself to prove characteristics. If we can prove the characteristics are true about the shape we have above, we can claim that it is a parallelogram. For the next example, we are going to be proving that a polygon A, B, C, and D is a rhombus. So, just like in example 1, we're going to begin by proving what we know about a rhombus. In a rhombus, we can say that opposite sides are parallel. We can claim that all sides are congruent. And that would give us our shape. Let's start by proving algebraically that all opposite sides are parallel. Starting again with slopes, we're going to use the slope for AD. And to find the slope for AD, we'll take the difference of our y values, which is 0, minus 3, and the difference of our x values, -2 minus -1, which will leave you with -3 all over -1. So your slope should be 3 for AD. Again, we're trying to prove that AD is parallel to BD, or BC. So let's go ahead and find the slope here to prove that. MBC is equal to -3 minus 0 all over -1 minus 0, which will get us -3 over -1 and a final slope with a value of 3. So I can say for certain that AD is parallel to BC. Next, we have to find the slope of AB. Once more, we'll use the slope formula. So we'll use 0 minus 3 divided by 0 minus -1. The value you should have for your slope of AB is -3 over 1, or simply just -3. And finally, the slope of DC is equal to -3 minus 0 all over -1 minus -2, which will again get you a value of -3. So using this, we have proven that opposite sides are parallel, and now we need to prove that all sides are congruent. And to do that, we need to either use the Pythagorean theorem or the distance formula. In this case, I'm going to go ahead and use the Pythagorean theorem. Let's start with DC, so the measurement of DC. For this, I can say that to go from D to C, I have a height of 3, and then a base to get from D to C, of 1. So if I were to plug that into my formula, I would have DC is equal to the square root of 3 squared plus 1 squared, or the square root of 9 plus 1. Adding those together and taking the square root, we should get a value of about 4.2. Let's do the same for AB. AB will have a distance of the square root, your height, which is 1, 2, 3, so 3 squared, and then a base of 1. Filling in your formula, you should have 3 squared plus 1 squared, and again, we're going to be following the same steps as above. Since my numbers match for DC and AB, I'm just going to write my answer as 4.2. Let's check this for AD now. The length for AD is equal to the square root of the height, which is 3 as well, and the base of 1. We're going to be following the same math as before. 3 squared plus 1 squared, which is equal to 4.2. And again, one last time, we're going to be focusing on BC. BC has a base of 1 and a height of 3 as well. So fill in the formula for the distance of BC to be the square root of 3 squared plus 1 squared, which again will get us the same value of 4.2. Using the distance formula, we have just proven that all sides in this shape are congruent, so we can claim that this characteristic is also true. Now that we've proven algebraically that opposite sides are parallel and all sides are congruent, we can start our proof. So create your t-chart and start with your slopes, saying that MAD is equal to MBC, which is equal to 3, and also that MAB is equal to MDC, which is equal to -3. And again, if you're using a specific formula for it, your reason has to be the name of that formula. In this case, the slope formula. Now, since these slopes are equal for each different side, we can claim that AD is parallel to BC and that AB is parallel to DC. Your second statement should be side AD is parallel to BC and that AB is parallel to side DC. And this will be by the definition of parallel lines. Calling back to example 1, if we've just proven that we have opposite sides that are parallel, we can prove that our shape is a parallelogram. So your third statement here should be that ABCD is a parallelogram. By the definition of parallelogram. Now that we've proven we have a parallelogram, we need to prove that we have a rhombus. So again, now we need to prove congruency. Your next step should be to say that side DC is equal to side AB, which is equal to side AD, which is equal to side BC, and every side measurement is equal to 4.2 by the distance formula. And if we've just proven that all sides have equal measurements, then we have also just proven that side DC is congruent to side AB, which is congruent to side AD, which is congruent to side BC, by the definition of congruency. Again, now that we've proven that all opposite sides are parallel and that every side is congruent in this shape, we can end our proof. We've just proven that ABCD is a rhombus by the definition of a rhombus, or what makes it true. Next, we have our third example. And our third example is we have to prove that the polygon A, B, C, and D is a rectangle. So what we have to do first, like we have been doing, is we have to prove that opposite sides are parallel. And we also have to prove that we have perpendicular sides. Once we prove that we have perpendicular sides, we can prove one true fact about the rectangle that makes it unique, that all angles are 90 degrees. Once we prove all three facts, then we can claim that the shape is a rectangle. Let's start with our slopes. So the slope of AB is equal to the difference of our y's divided by the difference of our x's, which will give us -1 all over -2, or +1/2. Same thing goes for the slope of CD. We'll have -2 or -1 minus -2 all over 3 minus 1. That'll give us 1 over 2. We've just proven that AB is parallel to CD. Next, we'll prove the slopes of AD is equal to -1 minus 3 all over 3 minus 1, which is equal to -4 all over 2 to get us the full value of -2 for your slope. And finally, the slope of BC is equal to -2 minus 2 divided by 1 minus -1, getting us -4 over 2 for a final slope value of -2. Again, once more, with this we've just proven that AD is parallel to BC. So we can claim algebraically that opposite sides are parallel. Now we need to prove perpendicular. As mentioned in the earlier video, perpendicular sides have slopes that are opposite reciprocals of each other, which means that 1/2 is the opposite reciprocal of -2. So I can say that AB is perpendicular to AD and AB is perpendicular to BC, since this is the opposite reciprocal of both -2 for AD, and -2 for BC, which means that we do have perpendicular sides that exist. And if all sides are perpendicular, that means that by the definition of perpendicular, that every angle A, B, C, and D measures to 90. Knowing this, we can begin our proof. Create a statements and reasons chart and start by writing down your slopes. That slope AB is equal to slope CD, which is equal to 1/2. And again, write that the slope of AD is equal to the slope of BC, which is equal to -2. And the reason is by the slope formula. So now that we've proven what the slopes are, we can claim that AB is parallel to CD and AD is parallel to BC by the definition of parallel. And just like in examples 1 and 2, when you've proven opposite parallel sides, you've also proven that the shape ABCD is a parallelogram. By the definition of the shape. Now we need to prove what makes it unique from a parallelogram, and again, that goes back to the perpendicular sides. Knowing that we have opposite reciprocals, that means that side AB is perpendicular to side AD, and that AB is perpendicular to side BC, as well as side CD is perpendicular to AD, and that side CD is perpendicular to BC by the definition of perpendicular lines. Now, since we've proven that perpendicular sides exist, then by the definition of what perpendicular means, angles A, angle B, angle C, and angle D are all equal to 90 degrees by the definition of perpendicular. And now that we've proven that opposite sides are parallel, that we have perpendicular sides and 90-degree angles, we can claim that ABCD is a rectangle by the definition of the shape. And finally, we are going to prove when a shape is a square. So much like the rectangle, we are going to be proving much of the same things. We're going to prove that all opposite sides are parallel, that you have perpendicular sides, that all angles measure to 90 degrees. But the one thing that sets this proof apart is that we need to prove that all sides are congruent. So first, let's start with our slopes. Again, we are going to be following the same formula that we have been. The slope for AD is equal to 2 minus 4 all over negative 2 minus 0, which will get us a value of 1. The slope for AB is equal to 2 minus 4 all over 2 minus 0 to get us a slope value of negative 1. The slope for BC is equal to 0 minus 2 all over 0 minus 2 to get us a value of positive 1. And finally, the slope for CD is equal to 2 minus 0 all over negative 2 minus 0 to get a slope value of negative 1. With this, we are able to assume that we have opposite parallel sides and that we have perpendicular sides, since 1 is the opposite reciprocal of negative 1. And we're able to prove, since we have perpendicular sides, that A, B, C, D all have angles that measure to 90 degrees, but we still need to prove that sides are congruent, which means that we have to find the distance of every single side. To start, we'll find the distance of side AD, which means that we're going to take the difference of your base measurement, which is 2, and the height, which is 2. So under your radical, you should have 2 squared plus 2 squared, which gets us a value of the square root of 8. And the square root of 8 is about 2.8. Doing this again for side AB, we'll take the square root of the base measurement of 2 and the height of 2, which again, we have the same square root of 2 squared plus 2 squared, which will get us a value of 2.8. If you look here, every single side has the same horizontal distance and vertical distance of 2, both for BC and for CD. Since this is the case, and our rate of change for the horizontal and the vertical are the same on every side of our square, we can claim that side BC is equal to 2.8 and that side DC is equal to 2.8. Since we've just proven that every side is equal to 2.8, we can claim that all sides are congruent. Now that we've proven all of these about the shape algebraically, we need to write the formal proof. Below your notes, draw your statements and reasons chart. And to start, we'll begin with our slopes. That slope AD is equal to slope BC, which is equal to 1. And that slope AB is equal to slope CD, which is equal to negative 1 by the slope formula. And since we have two different sides with the same slope, that means that AD is parallel to side BC, and that side AB is parallel to side CD by the definition of parallel lines. And just like in our former examples, if we've proven that opposite sides are parallel, then that means that shape ABCD is a parallelogram. By the definition of the shape. Now, proving what makes it unique from a parallelogram, we're going to be focusing on the perpendicular sides, which means that AD is perpendicular to side AB, and that side AD is perpendicular to side CD, as well as side BC is perpendicular to side AB, and that side BC is perpendicular to side CD by the definition of perpendicular lines. Again, this is because since 1 is the opposite reciprocal of -1, that makes these two perpendicular to each other as well as these two. So if we've proven that perpendicular sides exist in this shape, we can claim that angle A, angle B, angle C, and angle D are all equal to 90 degrees by the definition of perpendicular. We've proven that we have opposite parallel lines, that we have perpendicular lines, as well as angles that measure to 90 degrees. What we need to do still is to prove that all sides are congruent. We need to first state the measurement, and that measurement is that side AD is equal to side AB is equal to side BC, which is equal to side DC at 2.8 by the distance formula, since it is what we use to find the value. Since we've proven that all four sides have an equal measurement of 2.8, by the definition of congruence, we can claim that side AD is congruent to side AB, which is congruent to side BC, which is congruent to side DC. Now that we've proven that every side is congruent, as well as perpendicular and parallel, we can finally claim that the shape ABCD is a square by the definition of said shape. And that is how you prove a polygon.